Hey there. In this video, we are going to look at what we call the power rule and also exponents on top of exponents and kind of how those differ and when we can use the power rule and when we just use the basically the order of exponents. So exponents express the number of times a certain expression, the base, is multiplied by itself. But what happens when we have an expression that includes an exponent of an exponent? And sometimes that might look like this. And sometimes that might look like this without any parentheses. And we want to try to figure out, is there a difference between the value of each of these two expressions? And there is actually a difference between these two values. So this one on the left, when we have the parentheses around the base and the first exponent, this one we can think of as the power rule. And we have two ways that we can essentially evaluate that. And we'll look at that here in a minute. And then this one over here, when we have no parentheses at all, that one we are going to use essentially the order of exponents to figure out what order we evaluate those in. So we will get two different answers on these problems because of where the parentheses are here and because of no parentheses being shown here. So our power rule is used when we have an example like this, where we have a base raised to a power and then a power on the outside. So there are two ways that we can think of these problems, and it really kind of depends if we can use both ways, depends on what the base is, whether it's numerical or if it's variable base. So either way, we can take a to the m raised to the n with the parentheses around a to the m, and we can multiply these two exponents together. So m times n, and that could be our new exponent. So that is one method. Now that will always work, but there's another method that you could do if you have a numerical base. And I'm going to show you those two options down here. So when we are raising a base with a power to another power, like 5 squared to the third power, your first option right here is to go ahead and use that power rule. So we can use the power rule. We can evaluate 2 times 3. And yes, it is 2 times 3. It is not 2 to the third power. It is 2 times 3 when it's written this way. 2 times 3 is 6. And 5 to the 6th power, either multiplying it out or knowing it, one of the two, probably more likely to multiply it out. If you had to do this, you would get 15,625. Now, the second way that you could evaluate this to get the same exact correct answer would be, because we have a numerical base inside the parentheses, unlike here where we had a variable base of a, when we have a numerical base raised to a number exponent, we can evaluate that. 5 squared is 25. So then you can do 25 to the third power. And for some people, that's easier than doing that 5 to the 6th power. So it really just depends on your comfort level and what you prefer. But we can evaluate in the parentheses first and not have to know that power rule of being able to multiply the 2 and the 3 together. So looking at the example that we looked at in the intro, 2 to the third squared, you have two options here. So I'm going to quickly look at both of those methods. The first method is to use the power rule. So with the power rule, we would multiply the 3 and the 2 together. The base would remain 2, and then 3 times 2 would become 6. And then you would evaluate 2 to the 6th power. And when you do 2 to the 6th power, you get 64. So that's going to be 64. Now, the second option here would be to evaluate the parentheses first, and 2 to the third power would be 8, and then we would have still to the second power. 8 to the second power would be 64. So either way works. It's whatever you prefer. Now, another example here where we have a variable base instead, you can't evaluate what's in the parentheses here because we don't have a number being raised to an exponent other than 1, essentially, that's on that 4. So here, there is no evaluating we can do in the parentheses, but what we can do is we can use the power rule to not only multiply the 3 by 2, but the actual base of 4 is also going to now be raised to the second power. So it's like distributing that 2 on the outside to every base in the parentheses. So that will be 4 to the second power, and then x to the third to the second. So that's like this, if I were to look at that portion alone. And 3 times 2 is what we would do using the power rule. And 3 times 2 is 6. So this would be x to the 6th power. And then we can evaluate 4 squared 4 squared is 16, so this would be 16x to the 6th power. So I wanted to show you that you can't always use this evaluating the parentheses option first, because if we don't have a number base being raised to an exponent, then we have to use that power rule to actually simplify. So looking at our second example, 2 to the 3rd power to the 2nd power. When we have no parentheses on this example, this was the second example we looked at in that intro example. So I do want to note that before we go into this, you are not likely to encounter expressions that include exponents of exponents. So you may choose to skip to the next lesson at this point, and that's up to you. So when you are raising an exponent directly to an exponent, you are actually going to imply that the parentheses are around the exponents up here first, and that's the portion you are going to do first. And then you will raise that base of a to whatever you get in this portion right here. So let me show you what I mean with this example here. So we would actually evaluate this 3 squared first, and it is not the power rule here because we don't have parentheses around the 2 to the 3rd power. So we're not multiplying the 3 and the 2 that are up here. We are actually raising 3 to the 2nd power. And when you do 3 to the 2nd power, you get 9. So this is really going to be 2 to the 9th power. And 2 to the 9th power, if you multiply it out or if you do it in your head, you will get 512. And so that would be our answer. So in comparison, we ended up with 64 on this portion and we got 512 on this example. So these were two very different examples and we did get different answers, but they don't look all that different. So just keep in mind that when we have the parentheses around the base in the first exponent here, we have to either evaluate this part first and then square it in this case, or we could multiply the exponent and the exponent here, and that would become our 2 to the 6th power. Either way, you get 64. As a reminder on this second example, we went ahead and when there are no parentheses, we assume that we work from the top down, and that would be this 3 squared first, which is 9. And so then we had 2 to the 9th power, which is 512. So that's kind of showing you your power rule and your exponents of exponents.